Hey people, I was going to assign this for homework, but I figured let me go through it in class instead. This was from 2017, problem number 4. This is the problem that totally blew my students away, and it generated a lot of memes online, baked potato memes from calculus. I think maybe it was the fourth problem. The students were worn down a lot. There's a lot of text up here. That kind of freaked them out as well. There's a lot of things going on in the problem. It's really not that bad of a problem, and I know I say that all the time, but it really wasn't. We went through it with them, and they understood it. So let me read through it, and I'll kind of explain it to you. So time t equals 0, a boiled potato is taken from a pot on a stove. I guess people boil potatoes. I bake them. And left to cool in the kitchen. That automatically made me think of Newton's law of cooling, things cooling down. The internal temperature of the potato is 91 degrees Celsius at time equals 0, so that's the initial temperature of the potato. Okay. The internal temperature of the potato is greater than 27 degrees Celsius for all times greater than 0. I'm not sure what that's all about. It might come up in the solution, I guess. The internal temperature of the potato at time t minutes can be modeled by the function h that satisfies the differential equation. Okay. So guys, what they've given you, that's the temperature of the potato. So the internal temperature can be modeled by a function that has the temperature of the potato versus time. So it's the rate of change of the temperature. It's the rate of change of temperature of the potato versus time. That's what that is. Rate of change of the temperature of the potato versus time. H of t, that's the temperature of the potato at time equals t. So I've got two things. I got H of t, which is the temperature of the potato, and I got the rate of change of the temperature of the potato. Okay? H of t is measures in degrees Celsius, and H0, guys, see, they freak you out. They already told you that. H of 0 is 91. Well, they told you that up here. When the potato came out of the water, it was 91 degrees Celsius. So H of 0, so all that is, that's the initial condition. Initial condition. Okay? So guys, there's a lot of words here. They tended to repeat themselves. Okay? The fact that they took the potato out of a pot on the stove, cool in the kitchen, who really cares? They end up telling you that again, so that was extraneous information. And it's greater than 27 degrees Celsius for all time. I'm not sure what that is, but we might need it. So a lot of information, but basically what you're down to is there's some function h of t, and there's a derivative, dh over dt. Okay? So they've given you those two things, and they've given you an initial condition. All right, so what do they want? Write an equation for the line tangent. Oh God, that should make you think. Y minus y1 equals m x minus x1. Okay, where m is y prime when x equals x1. Okay, they often ask you about tangent lines. That you should automatically think that. So write an equation of the tangent line to the graph at t equals 0, so they're telling you that's x sub 1, so x sub 1 is 0, okay? And I know from the initial condition, h sub 0 is 91, so I've got my initial conditions, and use it to approximate the temperature at time t equals 3, okay? So here we go. So guys, I need, part A, I need y minus y1 equals m x minus x1. Okay, so y is h of t. Okay, y1 is 91. They gave me that. X1 is 0. They gave me that. Okay, so m is dh over dt when x equals 0. If I plug it into the equation up here, okay, I get that equals negative 1/4 91 minus 27, which equals negative 16. Okay? Negative 16. So h of t, which is y, equals, let's see. I should do that how I usually do it. I don't want to freak you guys out. I'm just going to go right down here. So y minus 91 equals negative 16 x minus 0. Okay? Now they use t instead. So if I rearrange it, I get y equals 91 minus 16t. Okay? So I just went back to t because that's what you do. So that would be acceptable. Okay? And then that is worth, I'm seeing 2 points. Okay? 1 point to get the negative 16, 1 point to write the equation, and then guys, 1 point to use the approximation. So y of 3, which is really h of 3. It's the temperature when time equals 3. It's just 91 minus 16 times 3. And if you do that, you get 43 degrees Celsius. That's another point. Okay, so guys, a tangent line approximation problem. Y minus y1 equals m, x minus x1. This time they gave us x1 and y1, 0 and 91 degrees. They gave us an equation for the slope. I just plugged those initial conditions into the slope because the slope was a function of h. Okay, h is 0 is 91. I get the slope, I plug it in, and then I use it. So that's 3 points. Guys, I'll do parts B and C on the next video.